Welcome everyone to my YouTube channel Competition Valley. My name is Prashant Mohan Thakur, and today we are doing the second class on divisibility and remainder. So we'll start from where we left in our first class of divisibility. So we learned there some concepts. Okay, we learned that how to check numbers if it is divisible by 4. Okay, so check last two numbers. Okay, so I'll begin today right from here. So now there's one more very strange observation. Let's see this any number 8 2 5 4 5 7 7 5. The moment the number ends with 5, okay, so by 5, of course it has, even if it ends up with 0. Okay, so zero, and the second could be that check last number if it is 5. Okay, now I will be making some I'll be creating some concept and then some ways on these two platforms. So again, remember, for divisibility of 4 we need to check last two numbers. 5 we are checking the last number. Okay, so can we say over here that for 4, okay, let's do one thing. Let's check any number divisibility by, let's say, 8. Okay, any number. So let the number be 27124091961. Okay. Now we need to check this for 8. How do we go about doing that? Now again, the two reasons. If you remember, I explained you why do we check last two numbers for 4, because if any number A, B, C, D, E, F, once the number at the ones place and the 10 place are the only ones which would not get divided by 4, because 4 is not divided by 10. But over here this is 100th place, 1000, 100,000, and it would keep going on till million and billions. It would all divide by 4. So can we do something like this with 8 as well? If we try doing that, what would happen? Let's say there's a number A, B, C, D, E, F, G. So how do we write it? So we can write it over here as 10 to the power 6A plus 10 to the power 5B plus 10 to the power 4C, 10 to the power 3D, 10 to the power square E, 10 to the power 1F plus 10 to the power 0 Z. Now over here we see where does in this series the divisibility of 8 automatically starts from. So we will see over here that it's 1G actually, there's no scope over here. It's 10F, no scope over here. Over here 100, so 100, let's see if it is divided. So we can say no, 100 also not, but 1000 for sure. 1000, it is of course 825 I believe, and then it would keep going on and on and on and on. So we see that in 8, if we want to do with 8, for 4 we check last two. So how many? I see 1, 2 and 3. Why? Because I can see that these are the only 3 places which are not an automatic divisible or an automatic divisor or a multiple for 8. So for 8 we need to check the last 3 numbers. So if you check last 3 numbers, it is 961. So Now again, do not sum it up. I'm repeating this because if you sum it up, and that's why purposely I left these three numbers, because if you sum it up, it's 9 plus 6, 15 plus 1, 16. It would be divisible by 18, but do not do that. It's not to be summed up, it's to be seen as a number as a whole. So you see 18, 12, 96, but it leaves a remainder of 1. So it would not divide itself. But if you turn this into 0, it would easily divide and it would be divisible. But I'm still generalizing something, so I should not stop over here. Let me see the same thing for 16. Okay, so again we take a number, random number, and would be 9 2 7 1 5 2 5 8 1 1 8 0 or anything. Now we need to check for 16. So again, if we do the same thing, so we see that 16 would not divide. Let's see if it does or not. So 16 16 6 90, no. So 16 would not divide the ones position, the 10th position, the 100th position, and even the thousandth of the position. So 16 will be automatically a multiple or a factor of 10 to the power 4, which is a 10,000. So 10,000, if you divide 16 to, it will be 16 6 96, and then you get 4 0 16 2, so it will be 625. 625 into 16 will give us 10 to the power 4. So how much position we are checking? We are checking, if you are dividing up to 16, we are checking up to 1 2 3 and 4 position we are checking up to, isn't it? We are checking 10 to the power 0, 10 to the power 1, 10 to the power square, and we are adding 10 to the power 3 as well. So now are we in a position that we can conclude something? Okay, so let's see if we can conclude something from here. Let me take freeform. Let me just okay, I'll take the second case by 5, or let me try to do it over here. Considering that you have understood what I'm trying to tell you, I'm just rubbing this off over here so that I can just conclude something. So what we can conclude over here is, again I'm just bifurcating. There are two screens, you can assume it as. So what we can assume is, over here, any number A, B, C, D, E, F, G, H, for any number, if you want to check for such a number wherein 2 is to the power n, be it 4, see, we check for 4 is 2 to the power 4, we check for 8, it's 2 to the power q, we check for 16, 4. So whatever the value of n is, we just need to check for that number. So for 4 it is 2 values, so we are checking for, we check for 2 values. For 8 we check for 3 values, and for 16 we check for 4 values. Okay, see over here, very simple. How? I've already explained this as well, that if we do A into B, okay, if you break this and write it into the standard mathematical language, so this portion can be written as 10 to the power 7a plus 10 to the power 6b plus 10 to the power 5c plus 10 to the power 4d plus 10 to the power 3e plus 10 to the power square f plus 10 to the power 1g plus 10 to the power 0h. And if you see ones, tens, 100, 1000, 10,000, 100,000, million, 10 million, this is how it's going. Or in our Indian terms, it could be 1, 10, 100, 1000, 10,000, 1 lakh, 10 lakh, and then 1 crore. So we can write it over here. So we see for 4, this is not going to be a multiple, this is also not, but 104 would divide it. So for 4 we check 2 value for 4. For 8 would not divide 100 as well. So for 8 what we do? For 8 we check 3 values. For 16 we are checking 4 value again. For 16 we checking 4 value again. So aren't we doing something over here, that whatever is the power of 2, whatsoever is the power of 2, we are checking it up to that number. So for 32 we will be checking up to the 5. We will be checking up to over here to the 5th value. For 64 it will be till the I believe for 32 it was 5, so for 34 it will be to the 6th value. So this would keep going on. So this is what we have generalized over here, and the same is with 5 as well. So let's see. I want to check for 35. So simply by, if you want to check, if I want to see, okay, one number, if, or let me take a big number over here, let's say 2 7 2 5 8 9 5, or yeah. So if you want to check if it is with 5 or not, if there is just one 5, we can conclude that certainly it would be. But can we conclude the same for 25? It would be 25 or not? We cannot do that. But for 25, what if you want to check, we can see 2 7 2 5 1 0 or 5, sorry, 2 7 2 5 8 5 0. For 25 we can easily check that, okay, these two numbers would be easily done. Again, the same thing, the rules are the same. Let me delete this and then let me do this. We are checking this for 5. Again, let's say there's a number A, B, C, D, E, F, G. So we can write it as 10 to the power 6A into 10 to the power 5, B into 10 to the power 4, C into 10 to the power cube, D 10 to the power square plus 10 to the power F plus 0 G. So how do we go about that? Now when we need to check for 5, so once we are checking for 5, we know that there is no scope, it will not be divisible, but right from here, so 5, we have a good chance that it will be right from the 10th place, because 10 would divide 5 very easily. So right from here it will happen, but not for 25. So for 20, because 10 would not divide 25, so we have to look for another option. So 100 would divide 25. But if you want to check for 1000, again this is insufficient. If you want to check for 125, this would be insufficient because 100 would not divide 125. So we'll have to look for 1000. So what we have concluded from here as well, that just like we did for the 2 and the power, so it's exactly the same for the 5 and the power. So what we can conclude is, for any number in form of 2 to the power x or 5 to the power x, just check the x value on the numerator, and if that's divisible or multiple, done. And what here, x equal to any power 1 2 3 4, any power, simple. So we have done this for 2 and 5. So we have generalized something over here, and we have tried concluding it from that part. Okay, if you I will write it in a separate place over here. For 2x into 5x, it means or, it does not mean 2 into 5. Okay, it just means that or like or. Let me write it. So we can write it, just check the value of x and account accordingly. Observe the numerator I'll do some questions. So check if 98765 98 is divisible. Okay, hang on. 3 is divisible by 125. Okay, again for 125, how much we need to check for? 125 can be written as 5 into cube. So what we can do over here is we can look for 3 numbers at the end and we see if it is divisible by 9. So if 375 is divisible by 125, our job is done. I see it is done 3 times, I believe. So yes, it is divisible. Okay, I'll do another question. How we can do about it now? Okay, let's see. Check if 42876 okay and 6464 is divisible by 64. So if you remember our concept, 64 is 2 to the power 6, I believe. 2 into 2 into 2, 8, 16. So we need to check for n equals, so we have the power of n is 6, so we need to check for 6 last 6 digits. So 3 and 3 6, so we see 7 6 6 4 6 4. If it is divisible, our goal, we would achieve this goal very easily. Now we can further break it down. Okay, it's not that we have to divide, we can use some you can see 64, isn't it? So, or we can write it 2 to the power 6 over here. So it doesn't make a difference. So if you can further break 64 into 8 into 8, you can break it down. So even that would be fine. Or you can simply over here 64 or 1 is 12, and again 1 is okay. So I think it's not divisible by 60. It's not divisible, but what we can do otherwise is, again, we need not divide this long number. So 766464, it is divisible by what we can do, 8 into 8. 8 is again 2 cube. So try checking the last 3 digits, and if it is see for 2 cube 766464, if you divide it by 8 by 466, we can check it. 464 by 8, so 8540. Yeah, it is divisible. 540, so it is divisible. Yes, divisible. So it is divisible. Okay, so this is one other way just to simplify your calculation. So in division, that's you can understand, you need to understand one more thing, that we will be using this application while we are trying to, once we shift from division to remainder, that a remainder in division, divisor and remainders, or we can say, let me write numerator. Numerator is used, it's not numerator, it's denominator. Denominator is used multiple times. This is a concept we'll talk about this when we are doing the remainder. And that's what I have done. It doesn't matter over here. You can do simply over here. You can take this 8 by this, and you can do this 8 by 8, and still there would be no difference in the answer. Okay, so don't be surprised about that. So this is, we have done the basics. We have completed the basics of divisibility. We have done all those small and important numbers. We have also tried getting some generalized concept. So from our next class, we'll move ahead and we'll get to know, we'll do some questions, and also we'll go ahead and do the remaining part of remainder section, which is very, very important. And we'll know some new topics and how to go ahead and solve these questions in quick amount of time, in quick snap. Okay, so once again, thank you for your time. I hope you would have learned something good today, and you would have really enjoyed this session as well. So once again, this is Prashant, Mohan, Thakur on Competition Valley. Please feel free to reach me through this email, which is there in the description. And if you have any question, any query, please do not hesitate at all to reach me. Once again, thank you so much.